Okay, so yesterday the lesson was about the tangent ratio. Today we're going to talk about another two trig ratios. They are called sine and cosine. And those are the trig ratios that we're going to use in geometry. So yesterday you learned that tangent was opposite over adjacent. So tangent of an angle, you can use x or theta or whatever, is equal to the opposite side over the adjacent side. Well, today you're going to learn about another two trig ratios. And since you already know how to establish which side is opposite or adjacent to the angle and which side is the hypotenuse, then things should be a little easier now. Okay, so you already know that when you have a trig ratio, you're always going to have the ratio of two sides of a right triangle. And the sine ratio is going to be equal to the opposite side to the angle over the hypotenuse. So as you can see here, it's going to be equal to the side opposite to angle A over the hypotenuse. So I can say that sine of any angle is always going to be equal to the opposite side over the hypotenuse, okay? So sine is opposite over hypotenuse. So if you want to determine which side is opposite to angle A, here you can see they're asking for sine of angle A. What you need to do is locate angle A and establish which side is opposite to angle A, which would be the one across from angle A. So that's why they have over here BC over the hypotenuse, and hypotenuse is always across from the right angle. So that would be side AB. So sine of angle A would be side BC over side AB, or opposite over hypotenuse. The cosine ratio is always going to be equal to the ratio of the side adjacent to the angle over the hypotenuse. So in this case here, so I'm going to put it over here, cosine of the angle is always going to be equal to the adjacent side over the hypotenuse. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent of the angle is opposite over adjacent. So in this case, cosine of angle A would be the side adjacent to angle A, which in this case would be this side over here. This is the side adjacent because it's one of the sides of angle A. And it's the side that is not the hypotenuse. Hypotenuse never changes. This is the hypotenuse. So if we're talking about angle A, this side would be adjacent. That was the opposite side. So cosine of angle A would be equal to side AC over side AB, or adjacent over hypotenuse. Okay, so now you have the three trig ratios that we're going to be using throughout this unit. One way to remember it that students use is by using SO, CA, TOA. So what that means is that sine is equal to the opposite side over the hypotenuse, cosine of the angle is equal to the adjacent side over the hypotenuse, and tangent of the angle is always equal to the opposite side over the adjacent side. So that is just a way to try to help you remember what those trig ratios are. Okay? So then here you have an example of how you can determine the sine and cosine trig ratios. So if you're talking about angle D, as you can see here, oops, let me just erase this and go back here. So as you can see, the letter A is talking about angle D. So angle D, the first thing I would do is find where angle D is, which in this case is here. And then from that angle's perspective, I will determine which side is opposite and which side is the hypotenuse. The hypotenuse is always across from the right angle, so that is H. And the side across from angle D would be your opposite side. So sine of angle D would be equal to the length of the leg opposite to angle D, which in this case is side EF, which measures 8 units, over the length of the hypotenuse, which in this case is side DF, which measures 17 units. If you enter that on the calculator, all this means is 8 divided by 17, you get that ratio. Okay, so you can write the value for sine of angle D as a decimal, or you can write it as a ratio. For cosine of angle D, now things change. So cosine, if you remember what I mentioned before, is always the ratio of the adjacent side over the hypotenuse. So if you're talking about angle D once again, which is over here, I can say I know that 8 is the opposite. So the side adjacent to angle D would be this side over here, which is side DE over the hypotenuse, which is still the 17 unit side, or side DF. And that gives you, if you enter on the calculator, 15 divided by 17, you get 0.882. Okay? And then the last two trig ratios are still sine and cosine, but this time we're not going to use angle D. We're going to use angle F. Okay? So now I work from this angle's perspective. Let's choose green, just to be different. So, oh, I want this one. Okay, so let me just erase this one, and I just want to make sure I will use a different color. And so if we're working from angle F's perspective, that's the one we're talking about now. So the side opposite to angle F would be side DE, which is the side across from angle F. So that would be opposite. And the hypotenuse still across from the right angle. And what is left over is your adjacent side. So sine of angle F would be equal to 15 over 17, because the side opposite to angle F is 15 units, hypotenuse 17. If you enter on the calculator, once again, 15 divided by 17, you're going to get this decimal over here, okay? And as far as cosine goes, cosine of angle F should be equal to the adjacent side, which is 8, over the hypotenuse, which is 17. And then you can also enter that on the calculator and get your decimal, which should be this one. Okay, so that's pretty straightforward. That's what you're going to be working with today. And then you're going to fill out a Google Forms for me. There are a couple questions still on tangent. And then tomorrow we're going to build on that. Okay, thanks so much.